Hello, everyone. I'm very glad to see you. I do not actually see you, but I'd rather see the number of you already joining to today's webinar, Inspiration Station, Driving Change Through Stakeholder Cooperation for Green Futures, which is supported by Interreg Baltic Sea Region and done within the project Enercracy. Today, we are going to go through different initiatives in the 5 countries that the project operates in to see how the cooperation is performed to enable energy communities, prosumerism, and green futures throughout particular cases to make you a bit more inspired about the ways how we can proceed, cooperate jointly to work for a better life. The Enercracy project itself, it's all about transition in municipalities, particularly in relation to climate and energy. We work around energy communities, prosumerism, wind and solar technologies to bring municipalities to better energy democracies with decentralized and community-driven energy being the key element of this transition, and to see how municipalities can support such initiatives through their energy and climate planning. And now we are already going to quickly go to the first presentation, but before that, there is a very short note how we're going to proceed. Every presentation will be 15 minutes. Then it will be followed up by 5 minutes of Q&A. For Q&A, please use the feature of Q&A or chat. I will read your questions that you provide to the presenter. But if you need more information, the presentations will be uploaded to our project website afterwards, so you can easily look them and also see the contacts of a contact person to talk more about how their initiative could be brought up, for instance, in your particular case. But without further ado, we kindly invite first speaker, Marcus Paulsson, the energy strategist and project manager at Lund Municipality, Sweden, to present very interesting technology, EnergyNet, and how it was used in one district in Lund, Sweden. So the floor is yours.
Microphone.
Yes.
Thank you very much for this introduction and for inviting me to this seminar. I would like to, well, I was just introduced being a city official for the city of Lund in southern Sweden. I will now share my screen. Yes. We talk about internetified energy as a driver for energy communities, and I will show you more in details about this. And it was around a year ago that we named this solution EnergyNet. So things happen quickly at the moment, actually. But first of all, Lund is a city in southernmost Sweden and hosts the largest Lund University of Scandinavia, which makes Lund and the Scania region one of the most innovative regions of Europe. Lund has about 130,000 inhabitants in the municipality. And the students and the university has around 45,000 students. So as you understand, this has a major impact on almost any part of our life in Lund. It has also a practical impact that we host 2 large-scale research facilities, MAX4 and ESS. Now, MAX4 is owned by Lund University, and ESS is a European consortium, European Spallation Source. And these are like material research, a particle accelerator for material research. And they generate a lot of heat. So we utilize this heat into the city as district heating. And when ESS is up and running and finished, it will heat around 20% of the entire city. And we have so much heat now that we even can use it for absorption cooling. So science now both heats and cools the city. It's a bit off topic today, but it gives a bit of perspective of where Lund is at the moment. So my main topic today is Coaction Lund. It is a cooperative system demonstrator on how to build a climate neutral city in collaboration between the city, the society, and mainly the companies in Lund. And we do that in 3 parts. We have this, what we call hub, where we cooperate and exchange experience and things like that. And then we work with mobility, because mobility stands for a little bit more than 50% our greenhouse gas emissions. But we also do work with energy. Energy used to be around 50% of our emissions, but has now decreased to below 3% due to an intensive work, especially with our district heating, and making it fossil free. But we still need to work with the energy situation because it is the fundamentals to be able to decarbonize other sectors of society. So we work with them together. And one of the things that we work with in this energy arena is a sorry. First, we met this guy. He's called Jonas Birgersson, and he transformed actually the internet, the way how we work with internet in the 90s. And now he thinks that we could do the same thing with electricity. And it's actually thanks to him that you have low fixed costs for your internet connection globally, because he was the first one to introduce that. Before that, we paid by the minute to use internet, but he changed that. He thinks now we can do a similar journey with electricity. And this is what we call the internetification of energy systems. And as I said, this is one of the parts that we work on Coaction Lund. We have other parts as well, but it is one of the bigger ones. And the fundamentals is that energy net is a distributed way of distribute energy. It is a new grid architecture that gives the electricity grid new abilities. And it's based on the same logic as internet, the same architecture as internet, but it uses power electronics instead of as the switch, as the router in this case. And this technology has advanced tremendously the last year thanks to electrical vehicles, which makes this new architecture possible. And why is this important? It is important because we want to utilize the very cheap energy that we know comes from renewable energy. And renewable energy are distributed resources. And to be able to harness that in the best possible way, we also need distributed energy grids so that we can use it like this in the best way. Because the trends for renewable energy, the price performance is amazing. The cost goes down and the performance goes up, which makes this the cheapest form of energy. It doesn't have any running cost, doesn't have any fuel cost, just have an installation cost, which make this very compatible. And how does then energy net work? Well, in this case, we have this simplest situation with one buildings. You put an energy router, which is symbolized by this green cylinder with arrows. You put that behind your electricity meter and then connect it to the building. That makes it possible now to build an ELAN within this building, because this router functions as a firewall. And behind this firewall, you can build your own grid that you can have your own control over. So it makes it ideal to connect different assets that you have, like PV panels, like batteries, like EV chargers. And all these run on direct current. So not to waste any energy, you use direct current the whole way between the router and these assets. And it handles it all. And all of this is now a grid within the building. So even if the power is lost from the overlaying grid, you still can utilize all these assets within your local grid, which in this case is the building. So if the power fails and you have solar, or if you have batteries, you don't even notice this within the building because it keeps on feeding the need. And that is automatically. You don't have to do any manual switch or anything like that. But it becomes even more interesting when you connect it to the next building, your neighbor. And then they also have an energy router, and these two communicate with each other and then share energy between each other. And this becomes then the local grid, still behind the meter, and still with this security feature that it's an own automatically separated grid, but at the same time always connected to the overlaying grid. But it's even more interesting when you turn this into a community. So a whole neighborhood is connected to each other, and then they can share energy between themselves, and they can share that at whatever cost they want. They can set a price for because this produces a local market. So they can set their own price on energy, but also their own price of the transfer cost, which is typically very low. And all this is then done behind the meters, and it can still be beneficial for the grid owner, because in this case it's connected to two net stations of the overlaying grid, and the traditional grid owner can then choose how to feed this area, from the right one or from the left one, depending on their situation, making it possible for them to optimize and cut peaks and so on. So it's like becomes a flexibility asset in the eyes of the grid owner. So what you need to be able to do this, you need some core components. You need an operator. Of course, we always need an operator, someone that makes sure that this functions all the time. You need an open language, which is the energy protocol, to be able to make all these assets to talk to each other, because it's based on communication. You need these routers that I showed you, the green cylinders, but you also need some storage. You need a small amount of storage all the time, but it's preferable. It's good to have a lot of storage, because then you can steer this much more. Why you need storage is that this is not a real real-time system. It's just a near real-time system. So it needs a small buffering capacity. And then you also need the cables between these routers to make them connect directly to each other. And that makes this mesh-like grid. This makes it possible to handle the different assets at different levels. Infrastructure at one, the gadgets and so on at one level, the marketplace, the billing, the steering at the OESO level. And then on top of that, you can have third parties delivering services to this as different kind of digital services that will be helpful for the owner of these and the users of these grids. So this is the fundamentals. Where are we? Well, we have this first site, which is in Brunnshög in Lund, which is our development area. We're building a lot of new housing there. We will, when it's finished, we will have 40,000 living and working in this area. So it's a big development area. And this first site was inaugurated in April last year, just a few days after the Energy Protocol was published at the open source. So it's free to use for everybody. But we don't stop there. We are now building this new case, which we call our commercial pilot. And that is 10 houses, 10 old houses from the 1960s that today uses about 1 gigawatt hour of electricity. And you can see all the connection points, all the meters symbolized by circles in the picture. With the installation of new photovoltaic panels to an extent that was not permitted by the grid owner, they said, this is so much we cannot handle this in the old grid. But with this new grid, we can handle an unlimited amount of PV panels on the roof. Investments in batteries, investment in these routers, and also some new cables in the ground. The situation after that is that we will decrease, the simulations show that we will decrease the purchased energy by 60% and also lower the total fuse, that is the connection size by 50%, making this profitable for the building owners. And this is under installation and will be finished before the summer. So then you're very much welcome to come and visit us. So to sum up, why neighborhood energy sharing network? It is resilient. There is no single point of failure. In a mesh or a distributed system, it's very difficult to block out energy because it will route different routes if needed, and that's for it will be very secure. It unlocks the possibility to install a massive amount of local renewable energy production. And that is a game changer compared to today's situation where the traditional grid is the bottleneck. And this is profitable, which means that this will be paid by the private investors that wants to have the system. So we don't need a lot of subsidies or things like that. So there's a good business case that would drive this market, and it would have zero technical impact on the traditional grid. Thank you. Questions?
Thank you, Marcus, once again. I wanted to, before going into the comments, comment and somewhat congratulate on the fact that cooperation itself within your coaction loan strategy is put on the same level as also decarbonization of the mobility and energy sectors, which is a very good progression in regards to developing solutions that are not only technically feasible, but also that are rooted in societies and communities that you operate within. Since right now I do not see any comments yet in chat, I will ask my first. For me, the development of the solution is very interesting, but I wondered whether already on the level of the piloting, you observed any challenges in regards to cooperation with the different stakeholders to being able to start developing this solution practically on the ground?
Well, of course, it takes this is a novelty, so it takes a lot of convincing to get it started, to talk to the different partners. In this first case, there was 2 properties with 2 different owners, so we had to talk to both of them, and also the city, and that they wanted to participate in this sharing. And we had actually 2, 3 other sites that we were looking into, but this was the most favorable for the piloting. Yes, talking to people and then convincing them this is something we should try.
Thank you. And I see there is one question in the Q&A section, which basically asks how can the DC mesh network overall be cheaper to build than the Shape AC network?
Sorry, I didn't get that.
I will reread this question, or if yes, how can the DC that requires fat cables mesh network be cheaper to build than the Starshape AC network?
Well, it's the 2 things. First thing, it shouldn't, but due to legislations, the legislations in Europe, and I think worldwide actually, it's the AC networks are monopoly markets, and there are no drivers to be cost effective. That is one thing. The second thing is that we now build on electronics, and electronics becomes cheaper. Power electronics, becomes cheaper the more we build of it. And this has not been the case with traditional transformers and so on. So there is a technical advantage of this new system, and these 2 combined makes it cheaper.
Yes, thank you. Looking at the time, I will take 2 more questions, and I see them in chat. First one being, what is the contribution of residents or homeowners in this initiative? And the second part of the same question is only the cost of it or more involvement? So this is the question 1, and you can at the same time also answer the second one as well. How did you get the grid operators on the board for such installments? So 2 parts, 1 residents and then grid operators.
Well, the residents of this building it's rental apartments, so they're only involved indirectly. But they will benefit from cheaper electricity. So because it's locally produced, and so they buy it from the property owner, the housing owner. So no, they are not directly involved in this situation. But eventually, as this spreads, they will be. but at the current situation, they are only indirectly involved. And the second question,
And second part was the grid operators. Yes, exactly.
In the first case, they were not involved at all. They don't have to, because this is legal to do behind the meter, so there was no involvement. But in the second one, the new one, they are involved because it does affect them, and now they want to see how does it affect them, and they want to investigate that.
Yes.
Yep.
Thank you. Thank you very much for your time and for fruitful discussions, and also hearing about EnergyNet was very exciting. As someone working in also local energy sharing, I've heard about this technology a lot, so I'm very glad to also see it in work, actually. But with that, we have to move on. And if you have any additional comments in chat, please remember that Marcus' slides, as well as everyone else's, will be available on our website, and you can contact them to ask any questions that you have about the technology and the developments as well. But we have to move, and our next speaker is from Podkarpackie region in Poland, and we are going to Anna Loganowicz, going to present the presentation named "Everything is Connected: Air Quality Improvements as a Starting Point for Rapid Energy Transition in the Project Podkarpackie Live and Breathe." So the floor is yours, Anna.
Thank you. Jak co mam z tym zrobić dalej? Udostępniłam. Okay. I needed the help.
Trzymamy chwileczkę.
Okno daj.
Teraz.
Okay. Nie widzę. I can see my presentation. Jeszcze raz.
Teraz nie widać, czyli coś ci tam włączył. Prezentacji.
No jest prezentacja. No jest. Okej.
Kraj trendy na całość.
Good morning. My name is Anna Loganowicz. I'm the manager of the project Live Podkarpackie. I'm happy I'm here because I had technical issues last time to connect. Today I'm a success. The Live Podkarpackie project is aimed at improvement of air quality, but it also includes the part regarding the energy transition. The project objective is implementation of the air quality plan for the Podkarpackie Voivodeship and effective use of available EU and national funds allocated to improving air quality and energy efficiency. Project implementation period is 10 years from 2024 to the end of 2033. Total project budget is 23,400,000 euros, which of 60% over 14 million euros is EU co-financing, and 35% over 8 million euros derives from the National Fund of Environmental Protection and Water Management. The project is implemented by the Podkarpackie Voivodeship with 61 municipalities. The Rzeszów Regional Development Agency, 2 associations, 1 research institution, and 1 partner from Slovakia. The project is based on 4 pillars, which are specific objectives. The first pillar is reducing the impact of energy poverty among the residents of the Podkarpackie Voivodeship. The second one, development and implementation of a regional energy management system. The third one, increasing the level of air quality and energy efficiency awareness among residents of our region. And the last one, more effective use of spatial planning tools to improve air quality in cities. Under the Pillar 1, the network of advisors has been established. It includes 61 air and energy advisors in municipalities participating in the project, 4 sub-regional business and energy advisors providing support to non-project municipalities, and 5 energy management advisors. Advisors were equipped with laptops, carbon monoxide detectors, and moisture meters. They are also provided with knowledge. Many thematic workshops are organized for them by the coordinated beneficiary. Advisors are also participating in the postgraduate studies. Air and energy advisors provide support to local governments in obtaining funds for local investments and projects in the field of improvement of air quality and energy efficiency. They also cooperate with municipal offices units responsible for spatial planning in order to include air quality and energy efficiency issues into local strategic documents. They also conduct work regarding implementation of blue-green infrastructure, such as creating meadow flowers, green bus stops, walls, roofs, pocket gardens, and so on. Advisors also provides assistance to residents in obtaining financial sources for replacement of obsolete boilers for solid fuels, thermomodernization of buildings, or installation of renewable energy sources. That assistance includes various kinds of free consultation on possible solutions and available financial sources, as well as preparing application forms. Advisors pay a special attention to impoverished people at risk of energy poverty. They cooperate with municipal or urban social welfare centers to identify such individuals and then to provide them with direct support. Another task of advisors is to conduct controls of household furnaces to assess the compliance with the bans introduced by the anti-smoke resolution, especially the prohibition of waste incineration. At the same time, they educate controlled residents, pointing out possible solutions and financing sources. Another task is to conduct, also educational campaigns, especially during outdoor or indoor local events. They also organize meetings with local leaders, such as, for instance, doctors, rural housewives clubs, volunteer fire brigades, departments, and so on. Within the structure of the Rzeszów Regional Development Agency, 4 sub-regional business and energy advisors have been hired. They provide support mainly to municipalities not participating in the project. They, as well as like municipal advisors, they conduct educational campaigns in those not participating municipalities, organize meetings with local leaders, and meetings with employees of social welfare centers. They provide support to local governments in obtaining financial sources for local projects. Sub-regional advisors also identify buildings requiring thermomodernization by conducting thermal imaging camera studies. They support all municipalities of our region. And they also participate in inspection of household heating systems due to carrying out the anti-smog drone actions. Pillar 2. Under this pillar, the pilot regarding rational energy management in the municipality is being developed and tested in 5 municipalities. At the end of the pilot, of each of those municipalities will receive the individual model of rational energy management in the municipality, including the solution tailored to local needs and conditions. That models will include the program of energy managing and actions, activities undertaken by residents, municipalities, entrepreneurs, as well as set of investments connected to financial sources. All of this built on goals indicated by the municipality, such as, for instance, green energy production, energy storage, green transportation, development of local energy communities, and so on. Those pilot municipalities differ. They are different size, population, urban, rural, different potential conditions, and so on. And we expect that due to those differences, those individual models will be implemented in other municipalities of our region and maybe wider. As part of the pilot, the energy management team was established in each of those pilot municipality, as well as the energy management advisor position has been created. Advisors' tasks are conducting analysis of energy consumption in public buildings, carrying out energy audits and preparing energy consumption balances, and conducting analysis of potential of public buildings to install photovoltaic panels, solar panels with energy storage. Data collected by advisors are presented to energy management team, and on the basis of the data, the team decides on local strategic investments. Advisors will be supported by, in their work, will be supported in the Smart Energy Management System, an IT tool which is being developed by the Rzeszów Regional Development Agency. SEMS will conduct analysis of energy consumption in buildings, in collecting real-time data based on measure equipment installed in buildings. Will generate automatic alerts to signal results deviating from assumed standards, and generate reports, charts, graphs, and so on. Advisors also conduct educational campaigns, one aimed at public sector employees on rational energy use, and another one targeting residents to encourage them to increase green areas. And the last part of Pillar 2, our pilot, is the social energy incubator, which has been established within the structure of RRDA. The incubator is a regional, an advisory body operating at a regional level, and it provides support to local governments in the field of identification of local energy needs, preparation, necessary investment, and providing economic, legal, and organizational advisory support. It also organizes workshops and trainings on development of local energy communities and renewable energy sources for all municipalities of our region. Pillar 3, it regards educational campaigns. Besides local campaigns, which I mentioned before, the coordinating beneficiary will conduct regional campaigns targeting residents in general, and it will regard such issues as impact of air pollutants on human health and practical issues, for instance, optimizing heating systems. Another kind of campaigns, awareness raising campaign targeting children and youth. The third one, also awareness raising, but aimed at people socially excluded at risk of energy poverty. And the last one, campaign promoting activities carried out under the project and achieved results. The coordinator beneficiary also organizes competitions for municipalities, and the municipality with the best ecological effect will be awarded with the title the Smog-Free Municipality. And the one with the most interesting solution regarding green-blue infrastructure will be awarded the title the Green Municipality. Winners will be announced during the conference organized by us, the coordinated beneficiary. Also financed prizes are envisaged. A local air quality information system in 5 municipalities will be established. It will include, it will be done this year. It will include meters measuring levels of particulate matters PM10, PM2.5, and benzalfapiran, and results will be displayed on LED monitors, and the system will have an educational role. On pillar 4, I mentioned about this pillar when I was talking about air and energy advisors' tasks. I will add that 5 pilot municipalities are developing the municipal quality plans for climate change. And we will organize, the coordinating beneficiary will organize conferences to promote good practice and actions taken by municipalities in the field of using special planning and strategic documents and blue-green infrastructure. And expected impacts of our project, at least 48% increase in primary renewable energy production by the end of the project, a reduction of CO2, PM10, PM2.5, and benzalfapiran, and also increasing green areas by at least over 260 hectares by the end of our project. Thank you for your attention.
Thank you. Once again, it's extremely nice to see that, just a starting point of thinking how actually you can improve air quality in the region can bring so many different actions at the same time. So it was very lovely to see in what pathways and what pillars you operate within with a single goal of improving air quality, but also bringing energy transition on the ground with the people supporting. Um, Here, I do not see right now any questions in Q&A, but I have a couple of questions myself right now. And I most probably would like to start with the question, why do you think that municipalities in the first place are the key agents in energy transition?
Municipalities play a crucial role in the energy transition because they are the closest level of the government to citizens. It gives them the direct understanding of local needs and challenges. And they are also responsible for spatial planning, as I mentioned. Also, public infrastructure, transportation, providing energy services, and that's why they are able to implement local policies and different kinds of projects in the field of projects to improve energy efficiency, reduce energy poverty, or promotion installation of renewable energy sources. They can also mobilize resources and funding, for instance, from national programs, EU funds, or local budgets, or they provide assistance to residents to obtain funds for their investments in the field of improvement of air quality and energy efficiency. They are also essential in improvement of awareness among residents. I also said about it, and they are also leaders in development of local energy communities, as they are aware of benefits such as lower energy costs, increased energy security, improved air quality, created new jobs, and so on. In Poland, most of local energy communities are energy cooperatives established by municipalities together with public entities such as schools, hospitals, libraries, etc. I hope they are a good example for individuals to encourage them to participate in such cooperatives and maybe another form. And we see growing interest from the side of individuals in participating in that way.
Thank you. At the same time, you somewhat managed to answer also a lot of questions, other questions that I had. Thank you for such a comprehensive mapping of the situation. And we have one more question right now in the comments, and it is, how did you deal with opposition overall to the topic of energy transition working in your municipalities?
So I can see that question.
If you go to Q&A, chat
yes,
Q&A, there is...
yeah. Okay.
So, paraphrasing, how did you work around people opposing or being against energy, like renewable energy infrastructure and those things, if you can comment on it?
I think the most important is raising their awareness, talking to them, showing them benefits. Nothing talks to people as money. Showing lower energy costs, it's the main cause that can persuade them to join that initiative.
Thank you. And so this is all the time that we had. Once again, Anna, thank you very much for participating today. It was a great presentation about how you can go about in many different directions about improving air quality and facilitating energy transition. So once again, thank you very much.
Thank you.
We will go to the next speaker, and we'll talk about intelligent energy communities in North Karelia, Finland. And here I would like to kindly ask Kim Blomqvist, the project manager at Karelia University of Applied Sciences, Finland, to present the developments and the ongoing activities around intelligent energy communities. And I think everyone will be interested to hear what actually intelligent in this case means. So the floor is yours.
Thank you, Kirill, and thank you for the opportunity to participate in this webinar. So hello from the frosty city of Joensuu, eastern part of Finland, and my name is Kim Blomqvist, and I'm from Karelia University of Applied Sciences, and I will briefly introduce you our Smart Energy Communities project and show you how virtual energy communities, digital platforms, and peer-to-peer networks can support fair and flexible energy transition. So I will share my presentation briefly. So it should be seen right now.
Yes, we can see it.
Okay, thank you. So we can continue to the next slide. So Smart Energy Communities project is our project name, and we have two project main goals and main objectives. So first, we develop and have been developing different kind of operation models for different kind of virtual energy communities and creating digital twins for energy communities. So they're kind of test beds for us. And also peer-to-peer trading platforms for energy communities. And second, our main goal is to increasing energy community knowledge and awareness in our area and broadly across the Finland. So that's we kind of support the creation of energy communities regionally and nationally. So what have we done so far? So this project will develop digital platforms and EMS for different kind of energy communities. So first of all, we have developed an open and logic-based digital platform that works as an energy community management system. So their individuals and energy community members can monitoring their consumption and production. So this tailor-made EMS for energy communities enables monitoring, forecasting, and intelligent control of shared and individual energy resources based on prices and consumptions forecast and grid flexibility needs. And there is one picture of this EMS. It's named by Energy Star Energiatähti. And then we have this sustainability and LCI aspect for this project. So what we're going to contribute is this life cycle assessment is used in this project to evaluate environmental impacts and carbon footprints. So it's kind of adds a transparency and supports credible communication about the greenness of energy communities and how green they can be, and with different energy resources and for example PV systems. And we have these impacts of these virtual energy communities, including these peer-to-peer networks, results in this year. And here we have taken account also a little bit social impacts and risks also. So call it this social life cycle analysis. So what we have done also is to peer-to-peer networks in these energy communities, more like a digital twins, which are the key tool in our project. So we can mainly these digital twins allows us to simulate energy communities using a real-time consumption data and real or simulated production of PV and energy storages. So we can add different kind of energy resource components to our digital twins and energy communities. Depends, they can be, for example, energy storages or some kind of electricity flexibility needs for the grid. And this makes it possible to test new control strategies safely before real world deployment. So like I said before, we have a different kind of test beds which we are using these digital twins for these energy communities and peer-to-peer network. So these peer-to-peer networks turns these energy communities into active market participants, and they also operate alongside public electricity market and provide better internal price signals for the energy communities. Both producers and consumers benefit, while the community benefits the most. And at the moment, we have a digital twin which has been implemented for a virtual energy community formed by detached houses based on a real-time consumption profiles and real-time consumption data from the next generation electricity meters. And we have also this PV production data from the real operating environment, or we can simulate a small-scale production and different kind of energy resources. And we have also ongoing this integration of AI forecast models and peer-to-peer network and a trading platform which are ready in this year. So like I said, this peer-to-peer network makes an energy community an active market player, not just a consumer group. It provides more flexibility than an exchange electricity contract, more economically efficient than a common storage alone, and also a better price signal within the community, strengthening the social justice and energy justice also locally, and of course increases energy community self-sufficiency and makes a model attractivity also investors. And the price is determined by according to intra-community offerings, and it could be protected by a price cap, and it's not subsidized but the market base and still protected by P2P trading. Then we have also studied a role of electricity storages in virtual energy communities, and they play a central and essential role in virtual energy communities. So simulations have shown that storage is profitable when used in multiple purposes. So it has to be used in 24/7 storage in solar or wind energy, and using these storages capacity or power in energy arbitrage and reserve markets. And electricity storages also stabilize the energy community's internal market of the community. So it's an essential role, especially in the virtual energy communities and peer-to-peer network. Then we have also studied AI-based solutions in virtual energy communities. So usually optimizing different kind of energy flows requires an advanced data processing. So we have tested, for instance, AI-based deep reinforcement learning tool to control energy and minimizes cost in energy community, different kind of test cases in our digital twins. The results are quite promising, and especially in the apartment building profiles. And in further development in this year, the algorithm will be fine-tuned and possible new functions will be added in this EMS, which I mentioned before. And then we have also locally this virtual energy community pilot in Joensuu Elli Properties, which is a student housing company. So there is one Joensuu's Elli property where solar power productions exceeds the need. So there is a surplus production which is transferred to the local distribution network, and the overproduction is compensated virtually by the electricity supplier. So there is another property from Joensuu Elli which is using this surplus where there is no own PV production, and the location is about 3 kilometers away from the solar PV system property. So why virtual energy communities and peer-to-peer networks? Well, traditional energy communities are often limited by its location and maybe property boundaries, and virtual energy communities remove this barrier and allow broader participation, which is especially important for the sparsely populated areas like our area in here, Eastern Finland, and also for the energy justice and energy fairness when sharing energy. Virtual energy communities can also combine these digital platforms, P2P trading and energy storage and IA. So they can enable a more flexible, more fair and scalable energy system also in the sparsely populated areas. So in nutshell, the production in virtual energy communities can be optimized to where it most cost efficiency. So that was my presentation briefly. Thank you for your listening. I'm happy to answer for your questions.
Thank you, Kim, for a very exciting presentation. This was truly an interesting case of how also, as I somewhat said in the beginning, how to bring intelligence into energy communities. And I see already that in the Q&A there is one question. I will just read it. In this energy community, if the energy is not instantly consumed by one member, do you share the kilowatt hours with, or just kilowatts, with other members, or is it sold to the electricity trader and shared as virtual money?
It can be shared in internal peer-to-peer network, but it works along with the public grid, so it can be sold also where you get the most reasonable price for the energy. So it can be optimized from that point of view.
Okay. I think I had a second of a very disconnected internet. So,
Okay.
but I think thank you for the answer. And I also wanted to ask you a couple of questions from my side.
Yes,
Of course, this is the webinar about how stakeholders can cooperate to develop different energy solutions. So in your particular case, who were the main stakeholder groups that were participating and at the same time also are crucial to potentially expand this form of energy communities in Finland?
Well, the key stakeholders, of course, are the property owners and residents who can provide the physical assets and flexibility. And of course, our local energy companies and distribution system operators who enable the grid integration and market participation. At least they can show us what we can do and what we can not do. In addition, also these technology providers, different kind of digital platforms, energy storage and control systems. And we have also, of course, nationwide do a collaboration with the research and educational institutions. So we are sharing our information about these energy communities and other similar projects in Finland. And also our public authorities play an essential role. So this successful scaling requires a different kind of collaboration across this entire ecosystem rather than isolated actors. So I think those are the main stakeholders.
Great. Thank you once again very much. Since the time is running faster than all of us want, from our side, this would be all. Thank you, Kim, once again.
Thank you.
And now we move to a little break. We have a 10-minute break, but don't go anywhere because after this break, we are going to hear two more very exciting stories one about the development of a wind park in Latvia, and then we will hear about why, in the first place, Estonia as a country needs more energy agencies and stakeholders facilitating the transition. So stay here, but we will be back in 10 minutes. Welcome back. I hope you had a good rest for 10 minutes to think about what you just heard. And I hope that the next two presentations will excite you to the same extent as the first three. And we are going to head from Finland to Latvia. And we will hear a very exciting journey and story of development of a wind park in Kaigu Swamp. Sabine Alte, the development director of La Flora Ltd, will present how this came to be and what was the journey of conceptualizing the wind park with all of the challenges that we usually see operating in renewable energy sector in the Baltics. So Sabine, let's see you. We can see you. Then I can assure that we can hear you. And please, each time that you need, just say next. And I will proceed with sharing the screen.
Okay, thank you for your help. Hello to everyone. My name is Sabine Alta. As Kirill said, the Development Director of La Flora Ltd. And today I would like to share our story of transformation, a journey from peak to megawatt, from historically carbon-intensive industry to a future built on renewables. So this is not just a technological shift, it's about responsibility, land use change, and redefining how industrial companies can contribute to national energy security and climate goals. So La Flora's wind park is a symbol of that transition, practical, ambitious, and deeply rooted in the land we manage. And not to mention very hard story, which took us approximately 10 years. So next slide, please. For centuries, carbon-based energy sources shaped the world we live in today. As we know, they enabled industry, growth, and prosperity, but they also created long-term environmental costs. Now we are at the turning point. The same world that was built with carbon must be sustained by clean energy. Wind is not only an alternative for that, it is becoming a foundation for modern economies. This slide sets the tone, acknowledging the past while clearly choosing a different future. Moving further to the next one. So energy, peat, and gardening. Kirill, help me with the next slide, please. Peat has played a critical role in energy and agriculture, especially in Northern Europe. Sorry, previous one was something. Yes, historically, it was valued for its availability, reliability, and importance in early industrial development. Beyond energy, peat became essential for gardening and horticulture, supporting food production, forestry, and plant cultivation. For generations, peat extraction was not only an industry, but a way of life in many rural regions. Next slide. Is peat green today? So today, when Latvia is the largest exporter of peat products in the world, we face many consequences for that. So Latvian peat substrates are used globally and are essential to professional horticulture, supplying around 31% of European demand, not to mention Asia, Africa, etc. So the whole world knows Latvia by using our peat. This creates an important question. Can peat be considered green? Knowing the European Green Deal, knowing UN, Paris agreements, etc. The answer is complex. While peat supports sustainable food systems, its extraction also carries environmental impacts. This tension is exactly why transformation is necessary, especially for a company like us, which is in a sector already for 30 years. So next slide will tell us about modern challenges of the peat industry. So we face three major challenges, which is environmental, CO2 emissions and climate impact, which we are blamed for. Second, ecological, which is also why we are blamed for the effect on ecosystems and biodiversity. And the third one is more on our side, which is social and cultural, which means thousands of jobs and regional economies depend on this sector. So any transition must balance all three of them. Simply shutting industries down is not a solution. That's why we are very keen to work with the political sector, also with regulations in national level, also European level, even in UN level. So responsible transformation is solution, and this is what we are trying to show. So who are La Flora? In the next slide, we can see that we have been operating since 1995, and we are the largest national peat industry company in Latvia. We extract and process peat, producing substrates for agriculture, forestry, and food production. About 19% of our production is exported to nearly 100 countries all over the world. In 2024, the turnover reached 34.7 million euros, and we paid 6.1 million euros in taxes and employed 312 people. Here, I would like to say that we have season time for extraction, so it's approximately from April till October, depending from the weather. So in this time, this employed people is are around 500. So it's very important to mention that these numbers is bigger than average. And also the average salary in our sector is bigger than in any other industry at the regions. So this scale gives us both responsibility and opportunity to lead these changes. About land and recultivation. So recultivation, peat extraction is never planned without thinking about what comes next. From the very beginning, a decision is made on land use after extraction as required by regulation. And in the next slide, we can see that there are Cabinet of Ministers rules, which is this sector is very regulated, and we as a company are in better position maybe than our colleagues because we are the owners of our peatlands. So these peat bogs belongs to us, around 2,000 hectares, which is, I guess, we are the only company in the world who has this. So if rented peatlands can be recultivated by those strict rules, which comes from the government, then we as a company can manage to use this land recultivation plans for CO2 compensation to keep on extracting whilst doing such a projects like wind park, green industrial area, biodiversity, etc. So recultivation options include renaturalization, agriculture, forestry, water bodies, recreation. But in La Flora, these decisions are carefully planned, balancing both environmental impact, economic value, and long-term land sustainability. So in the next slide, you can see what's our vision about this. Our vision is to use bogs as land capital efficiently, responsibly, and in interest of society as a whole. So this vision aligns with the European Green Deal, the UN Sustainable Development Goals and Latvia's national priorities. And we believe industrial land can continue to create value long after peat extraction ends, including as a platform for renewable energy. So next slide, please. How we managed to build the park in a peat bog. The La Flora territory, where we have already built a wind park, covers 763 hectares, entirely owned and managed by us, by the company. So bog itself, it's over 5,000 years old, with average peat thickness 5 to 7 meters. So we started to extract this peat bog already in 1920s. So it took us, and we are still extracting it because it's not in one time. You cannot do it and manage it at one time. So it takes approximately 100 years. So today, 503 hectares are under cultivation, and still 260 hectares remain under extraction. This spatial planning makes it possible to gradually transition land use from extraction to renewable energy and new economic activity. So next slide will show us step 1, which is wind park. This transformation is the La Flora wind park owned by Latvenergo. What we did, we managed to do environmental impact assessment already in 2021. So we finished it. We got yes from all the stakeholders. And then we started to look for an investor because it's a very financially huge project. And we never wanted to be an energy seller. So this was the plan. So we made this project ready to build phase. And luckily, our partner in this is also a Latvian company, Latvian energy company, Latvenergo. So park includes 16 Nordex hybrid turbines, each with capacity of 6.8 megawatts, so the biggest ones in region, and total of 108 megawatts. It will generate approximately 350 gigawatt hours of electricity per year, enough to power tens of thousands of households. So the total investment exceeds 185 million euros, with more than 95 million invested by Latvian companies. So our partners were mainly 10 huge Latvian companies who gained from this project. So the money stayed in Latvia. This year is when we are gonna up and running this wind park. So in February, we are starting tests. And by end of June, we are planning to put the first megawatt in the grid. So what's the next step for us? So we needed this wind park to build our plans for the future. So we are looking not 7-year long term or 4-year till the next election. We are looking much further because we know how many resources we have. So we have resources around for around 50 years, which we want to still keep on extracting. But we at the same time we need to cover the CO2 and compensate what we do in those peatlands. So the next step is creating a green industrial area, an oasis of renewable energy. And in this case, plans include renewable energy installations, hydrogen production plant, large-scale solar park, greenhouse complexes, energy-intensive production facilities, and even hydrogen refueling station. Not to mention also, we are in negotiations about to build a data center in this area. This area will not only consume clean energy, but also produce new green value chains. This is our plan. So in next slide, you can see our goals. So mainly, we aim to offset emissions from our core operations, as I mentioned, by integrate renewable energy and modern emission-reducing technologies. This is how traditional industries can actively contribute to climate neutrality. And also our goal is to create the first green energy industrial park in the region, certified and fully aligned with sustainability principles. So one of the ending slides, next one, transformation of values. So this transition of LaFlora is both environmental necessity and economic opportunity for us. The shift from peat to wind is symbolic, but also deeply practical. It shows how existing industries can reinvent themselves instead of disappearing. Our call to action is clear. Support smart policies, long-term investment, and innovation that enables responsible transformation. And yes, so the last slide. LaFlora's journey from P to megawatt is still ongoing, but it already demonstrates that sustainable transformation is possible when vision, responsibility, and action come together. So thank you for your attention, and I look forward to your questions and discussion.
Thank you. It was a great presentation, and I think it is very important to acknowledge this discussion overall when we talk about the post-fossil transitions, because you hear a lot about coal regions transitioning away from coal, creating new opportunities for renewable energy, but we do not hear the same stories about peat, for instance. So it was very insightful and very interesting. I would like to start this discussion because I currently do not see any questions in the Q&A about the process of how the planning of the wind park came to be, how involved were the local residents of municipalities around the project, and how resistant they were towards something like this.
So basically, the story, I could talk about this week, but I will try to manage in few sentences. So we started this idea in 2015 when we, in this large area, when we said, yeah, there's a lot of wind. Let's monitor it. And we put the 50-meter tower to monitor the wind, and it showed good results. So our first plan was to build one windmill for our factory. Then these green ideas already. It wasn't that time when Green Deal stepped in, but it was already before. But we already saw some Green Deal starting points. So then we said, why just one? Let's do big or go home. So and this plan was built slowly, I would say. There was no regulations before us in Latvia about such a huge project. So we started and enrolled as first, actually, and that's why it was maybe heavier and but interesting, yes. And then we started, of course, this impact assessment. It was 2018 first meeting with the local communities, and it was nobody was against, and mainly because it's private land, so it's peat bog surrounded by forests. So no closest houses are around 1.2 kilometers. So, and there are only few of them at this point. And then also by the time of COVID, we had this final meeting, and when everybody said yes, of course there was questions about who gets carrots from that, but the energy system in Latvia is like you cannot really change it in a second. So you have to accept that there will be maybe in time some carrots. So those are the main questions. Only how to say. Against story we started to feel when we already started to build these windmills. Then this publicity about not building wind parks in Latvia started, but it was like for a few months and then it ended. So our success story is that also the local communities knows us as a company, as a stable company who gives a lot of employment already for 30 years. So everybody knows our name. So I think those were the main objectives why our story is ended happily.
I see that the only question in the Q&A resembled the same that I just asked you. So because of that, and because you ended on such a happy note, I would like just to say thank you for today's presentation and for the contribution to this webinar. And yes, thank you very much, Sabine.
Thank you. Thank you.
And now, as a final presentation of today's, we move up from Latvia to Estonia to answer a question. Why did the Estonian Islands create an energy agency for transition and independence? Presented by Taavi Liivandi, the consultant at Estonian Islands Energy Agency. The floor is yours.
Yes, hello. So I hope it's in a presentation mode now.
Yes, we can see it and it's in a presentation mode.
Okay, so basically, hello from my side also. We are a small and quite young energy agency from Estonia, from the islands on the west coast. We were established in basically end of 2024. What's the problem we are solving, or why the energy agency was started is basically that on the islands we have very little know-how of energy issues, and we see that the challenges are quite similar in our islands and also in other islands in Europe, and also the possibilities. Basically, from a historical point of view, the energy production in Estonia was on the eastern part of Estonia, where we produced energy from oil shale for the past like 100 years, and now the production is moving with PVs and wind parks towards western part and also towards islands. We have quite dispersed settlement. We have also old and energy consuming buildings, both public buildings and apartment buildings. We have old transportation fleet using mostly diesel or gas, and the need was that we have both for the local municipalities and for apartment unions and for the companies some kind of partner in this domain. Our founders, basically, here are some numbers also about islands. Total population is approximately 45,000. The most of it lives on the biggest island of Saaremaa, approximately 33,000. The next one is Hiiumaa, approximately 10,000, and then there are smaller ones. Ruhnu is the smallest one. In the winter time it's up to 100 people, and in the summertime it's like 400 people. And our founders are basically 6 biggest islands in Estonia: Saaremaa, Hiiumaa, Muhu, Kihnu, Ruhnu and Vormsi. The local entrepreneurial unions, the Hiiumaa and Saaremaa development centers, TalTech is Technical University's Kuressaare College, and we see that our bigger brother or bigger sister and the mentor is also TREA, who has been operating more than 15 years in Estonia and was the only energy agency. So we got a lot of help during the preparation of the project to the life funding scheme, and also during everyday work we also make quite a lot of cooperation with TREA. So we have quite a good network in Estonia in different fields, in academic, in state level, but we also are a part of different international projects. We are active member of FEDERAIN, which is the energy agency's European association, and we are active member of Clean Energy for EU Islands, which includes 30 islands all around Europe. Those include most of the big islands on the Baltic Sea, but also in the Mediterranean, but also in some European islands in the Caribbean and in the Indian Ocean also. For example, Reunion. So we have a lot of common issues, but we have a lot of differences also. And we are a member of BEIC, which is the Baltic Energy Islands Connect. So the most of common challenges and possibilities is with the Baltic Sea Islands. We are building up our energy service portfolio. Today the focus points are buildings, apartment buildings, municipality buildings, helping to renovate or preparing and helping to make the full renovation projects. Then is the mobility domain, helping to analyze full mobility solutions and the needs not only inside the island, but also between the islands, between the mainland, and not only to focus on concrete transportation possibilities, but for example ferries or buses, but take like a holistic view on mobility as itself. And we are also looking into the new possibilities. Is it electrification? Is it biogas? Is it hydrogen? Is it methanol? So on, so on. So with local municipalities and with state companies who are owning and giving the money to develop the needed infrastructure, then we are cooperating with them also. And one of the focus points is also helping to develop energy communities on the islands. but due to Estonian quite not so helpful regulations, we are, or like playing ground is quite narrow. So today we in Estonia can make energy communities only with direct line or with closed distribution network. We hope that at least for apartment unions we get some kind of new legislation in mid 2026, but it seems it is postponed to 2028. So with energy communities, it's not so good in Estonia at the moment. When we made the project for getting the grant from LIFE, we had to find and help to bring investments, energy domain related investments to the islands more than in the amount of more than 20 million. We have accomplished it in the first year already, and now we are finalizing the LIFE project, which will last until mid of 2027, and we are preparing for the next project, and also we are looking for other possibilities how to fund different projects. Are those SECAP or those climate municipality climate plans or whatsoever. So we are like the partner for municipalities also in the funding area. And I just mentioned that we have quite difficult start in the energy communities, but nevertheless we are now preparing for the first energy community as a not exchanging energy between different producers and customers, but the energy community is one client based, but the energy community acts as a financing scheme that community members can invest in the PVs and storage system, and we can make for example with Kärdla Sports Center some kind of PPA, long-term PPA. And the roadmap, basically, as I mentioned, Western Estonia and the islands have a huge potential in wind, in PV, in local biomass. So we are looking into different possibilities, and we are also looking not only where we could produce renewable energy, but who would be the consumer also. So we today the problem in our islands is not that we cannot produce. We have a lot of potential for producing, but we have declining consumption on the island, so we need a lot of consumption, while the cables and grid is not built up so strong for western part of Estonia, so we can't get like the produced energy to the mainland. So we need to find huge consumers on the island. And as the last presenter also showed, we have the same ideas, some vertical greenhouses, maybe some or one data center. So basically we are looking also into this possibilities. energy and mobility hubs, and also our like main concept is for the ports and also for municipality buildings, which most act also like resilience centers, that they will be also during the crisis like resilience centers, but when there is no crisis, they be like energy and mobility hubs for the local communities. And also we see that more and more need or attention has to be put in the food security also. So that's why also the idea of vertical greenhouses. The smallest island of Ruhnu is not connected to any grid, so today it's fully autonomous. Today, unfortunately, the system is like 50% is on diesel, so we hope and help to model a new solution that Ruhnu Island could be 100% renewable with solar, wind and battery storage. Key learnings from we are developer neutral, technology neutral. We look for the best solutions for the local communities. A lot of tailor-made solutions. We are moving towards data-driven decision making. Unfortunately, it's not so good at the moment. There are some kinds of data that is very easily accessible, but some kind of data is not automated. So we are working on a data management tool with which we could propose for the local municipalities which objects or investments should be prioritized. And basically that's it from my side. So
Thank you, Taavi, for a very interesting presentation. Also, during a very important point of time for you, as you mentioned, that the LIFE project that initially created the agencies on the somewhat finishing end, and right now you have to look around and see how also you can sustain your activities long term. I think this was very interesting discussion overall. I don't see any questions right now in the Q&A section, but in that case, I would ask myself first, how currently popular are your activities and your services, especially with the residents or different stakeholders around the islands?
Yeah, it has been quite a difficult year, the past year, 2025, while we had the local elections, and some of the parties made the number one issue, the anti-wind park issue, and also while we are right now, Estonia is planning the forced connection to Latvia via Saaremaa Island. Then some of the parties also took the high voltage line development as a main issue. So most of the people understand why we need energy, but again, there are some who just use it like for the political propaganda. So, but today again, everyone understands that we need to renovate the buildings. We need to think something about public transportation, and there is also the possibility when we go to, for example, electricity, then it's when it's locally produced, it's cheaper and so on. So everyone understands that there can be huge savings for the local municipalities and the state, and we are going with them like step by step. So we are looking for points of cooperation, not those where we are in different opinions. So
I think since there are once again no questions, and I feel like your final message of we know what we need to do, and most of the people understand what you need to do. So you need just more cooperation between the different people around to bring those ideas, to bring energy in a just way all around. I think it is very important. So with that, I would like once again to thank you, and once again thank all the presenters today for incredible presentations all around on the different topics of how action stimulates stakeholder cooperation in energy, around energy, and about energy. And with that, at least for a moment, that's it. Thank you very much. This is the second and currently the last webinar in the Inspiration Station series. But don't get too sad, because going forward, you will hear a lot about other updates that we have developed simultaneously with that. But with that, I thank all of you and wish you all the best today and every other day afterwards. Thank you.